Hello everyone, and welcome. Have you ever wondered how scientists can separate a mixture, like the different colors in a pen's ink? They often use a technique called chromatography. Today, we're going to dive into a very important concept within chromatography called the RF value. It sounds technical, but it's actually a simple and powerful tool for identifying substances. First, let's quickly understand chromatography. Think of it as a race. You have a racetrack, which in our case is usually a piece of paper. This is called the stationary phase because it doesn't move. Then you have something that starts the race and carries the runners along, like a wave of water. This is the mobile phase, which is a liquid solvent. The runners are the different chemicals in your mixture. Just like in a real race, some runners are faster than others. In chromatography, different chemicals travel up the paper at different speeds, causing them to separate from each other. So, where does the RF value fit in? The RF stands for retardation factor, and it's basically a number that helps us identify each of those chemical runners. It's a simple ratio calculated with a formula. RF equals the distance traveled by the substance divided by the distance traveled by the solvent. Let's break that down. When you run a chromatography experiment, you first draw a pencil line near the bottom of your paper. This is your starting line. You put a small spot of your mixture on this line. Then, you let the solvent, or mobile phase, travel up the paper. As it moves, it separates the mixture into different spots. To find the RF value, you need two measurements. First, you measure the distance from the starting line to the center of one of the separated spots. Let's say that's 4 centimeters. Second, you measure the distance from the starting line to the highest point the solvent reached. This is called the solvent front. Let's say the solvent traveled 8 centimeters. Now, you just divide. You take the spot's distance, 4 centimeters, and divide it by the solvent's distance, 8 centimeters. This gives you an RF value of 0.5. Why do we care about this number? The RF value is like a chemical's fingerprint under very specific conditions. If you use the same paper, the same solvent, and the same temperature, a particular chemical will always have the same RF value. This is incredibly useful. Scientists can compare the RF value of an unknown substance to the RF values of known substances to figure out what it is. An important thing to remember is that the RF value will always be a number between 0 and 1. It can't be more than 1 because the substance can never travel farther than the solvent that's carrying it. A value of 0 means the substance didn't move from the starting line at all. Thank you so much for watching today's video. If you learned something new and found this explanation helpful, please hit that like button and consider subscribing to our channel for more simple science breakdowns. Don't forget to ring the notification bell to stay updated. Your support truly helps us continue making these videos for everyone. See you next time.